In this video, we're going to find the domain of a function from 1.1. Two things that I'm looking for that will restrict my domain is going to be division by 0 or taking an even root of a negative number. Both of those things are bad in math. I'm not allowed to do that. By an even root, I mean a square root, fourth root, sixth root, so on and so forth, any even index on the root. Odd indexed roots don't matter here. They're not going to restrict my domain like that. So if I don't have any of those things going on here, then we are in great shape, and I don't have any bad numbers to take out of my domain. Don't have those things going on here, so my domain is going to be all real numbers, which can be written in interval notation as negative infinity to infinity. That's the entire number line, from as far left on the number line as I can go to as far right on the number line as I can go. Now let's find the domain of this function. I have division involved here. So 3 times x squared plus 1 is my factor denominator. X squared plus 1 is never going to be equal to 0. I can try. Let's try it. What number can I square and get -1? Not a real number. So there are no real numbers x that will cause me to divide by 0. I don't have any roots in this problem. So again, my domain is negative infinity to infinity. Now I can factor this denominator here into x plus 14 and x minus 14. When I set that equal to 0 and solve, x plus 14 equals 0, or x minus 14 equals 0, x equals -14, or x equals 14. Those are my two bad numbers that I'm actually not allowed to have, so I'm going to remove them from my number line, -14 and 14, and I'm allowed to have everything else. So I'm going to have the domain of negative infinity to -14, union -14 to 14, union 14 to infinity. That's not all going to fit in that little box, but that's what my domain is. Now let's look at my denominator here of x times x squared plus 4. The x squared plus 4 part is never going to be equal to 0, but the x part can equal 0. So x equals 0 is a bad number for my domain. I need to exclude that, and I'm allowed to have everything else of negative infinity to 0, union 0 to infinity. Now we have a square root, so 6x minus 24 isn't allowed to be negative, so it can be positive or equal to 0. 6x needs to be greater than or equal to 24, so x needs to be greater than or equal to 4. I write that in interval notation with a square bracket to the left saying that it can be equal to 4, and it goes to the right greater than all the way to positive infinity. 4 to infinity. Now this denominator isn't allowed to be 0, so absolute value of 2x plus 7 minus 3. We don't want that to be 0, so let's set it equal to 0. 2x plus 7 equals 3, which means 2x plus 7 equals -3, or 2x plus 7 equals 3. 2x is equal to a -10, meaning x is a -5. Or 2x is equal to a -4, meaning x is a -2. So those are numbers that I need to restrict. -5 or -2, and it's allowed to be everything else. So that would be negative infinity to -5, union -5 to -2, union -2 to infinity. Now that denominator is not allowed to be 0. So when I take x minus 9, I would normally say greater than or equal to 0 because it's inside a square root sign, but it's not allowed to be equal to 0 since it's in the denominator. So x needs to be strictly greater than 9. So my domain is going to be 9 to infinity, with 9 not included. And now the cube root of that big fraction is going to be the cube root of the top divided by the cube root of the bottom, like that. And I'm not worried about negatives inside those cube roots. They don't bother me because they're odd indexed roots. I'm only interested in that denominator being 0. So t squared minus t minus 6. I'm going to set it equal to 0, and I'm going to factor. T minus 3, t plus 2 equals 0. T equals 3 or t equals -2 are my bad numbers here. -2 is to the left of 3. It's allowed to be everything else. So we have negative infinity to -2, union -2 to 3, union 3 to infinity for our domain. That's it for this video. We'll come back next time and we will keep talking about 1.1. See you for the next video.